So looking at the increase in potential energy during this bench pressing session here. And so we do know that potential energy, the energy of position, is equal to the average force to get it into position times the distance traveled using that average force. And so in this case, we can say that the average force, we're told that it weighs about 800 newtons. And so we can plug that directly in. If they had just given us the mass and not the 800 newtons, then we would multiply the 85 times the 9.8, or mg, to get to this. But they saved us one step by providing the 800 newtons. And then lifting for 1 meter. So 1 meter higher, and we end up with 800 joules. Now, we do know that this is an increase in potential energy, and something we need to know is that potential energy is always relative to something. In other words, when this weight was lifted and we're saying it has so much potential energy, what is it relative to? And is it relative to the floor, if that the weights were laying on the floor? Or maybe there's a basement in this building, maybe they were there. Well, no, it's relative to the lowest position that she could bring those weights. So she lifted it from that low position to the upper position. So one thing that is worth noting is we're basically saying the change in potential energy, that final energy minus the initial energy, is our 800 joules. That's what we were able to increase the potential energy using the work of pushing that weight up.